Okay, so we're going to do TwoSum3, which is the data structure design. So it says design a data structure that accepts a stream of integers and checks if it has a pair of integers that sum up to a particular value. Implement the TwoSum class. So TwoSum initializes the TwoSum object with an empty array initially. Add is with a int number as a parameter. It adds the number to the data structure. And then find returns true if there exists any pair of numbers or sum. Is equal to value, otherwise it returns false. Okay, so first thing we're going to do, I think, is we're going to make a list of integers. We'll call it list, and we'll go and make a map of integer to integer as well. I think we'll need that. So when you call TwoSum, it initializes list. So a new list right here. When you add, we'll just do list dot add number, I think. Now find, so what we'll do is we'll initialize the map here. We don't need to initialize until we need to find it, I think. So, and find can be called on multiple values. So I don't want to, create the map and then have the same map and store values. So we'll initialize it here actually. And so we'll do list dot for each, I think, for each item in it. So Um, so if map dot so if it contains if it contains the item. No, hold on. It's so funny. TwoSum is the easiest one. So let's just remember how to do TwoSum. So first of all, we're given a list of input, right? 1, 3, 5, 4, 7, and find and a target value. So 4. So our target value. So what we do is for every element, we're going to store the difference of target minus the item into the map. So if map dot contains value minus item, right? If it has this, then we're gonna return true, I think. Right? If it has this, then we're gonna return true. No. Hold on. So the key is gonna be, yeah, key is gonna be the difference. So then otherwise what we'll do here, yeah, and otherwise what we're gonna do is do map dot put. We're gonna do value minus item, do item. So no, we'll do item, and we'll do value minus item. So okay, let's just remember this. So I don't think this is right. This doesn't seem right initially, but if we put the integer that we're at, and yeah, you know what? I think this is right. So okay, so what we're doing for every element in the list that we have. So our list, let's do a quick comment. So we have a list of 1, 3, 1, 3, 5, 4, 7, right? So 1, 3, 5, 4, 7. And our target is equal to 4. So first things first, item is going to be 1. 1, so 4 minus 1 is not in the map. So we'll continue. So we'll put 1 in the map, and then the value, which actually we probably don't even need a map. We can probably just do a set for this. but we'll see because we can probably just do a set. But anyways, um, yeah. So then the next item comes is 3, and our target is 4. So our map contains currently item, which was 1, and I'll do 4 minus 3 is 1. It contains it. Return true. Oh yeah, let's just do that. Let's make it a instead of a map, we'll make it a set. Um, and we'll call it set equals new hash set contains. Otherwise, we'll put the item, and then at the end of it, we would return false because it couldn't find anything, and we'll run code. Compile error. So list that for each is not right. For each item. Oh, I called it map still. It's called set. Set. Is it not for each? Is it for each like that? I didn't like this. So I like for the return value. I think I need to just do list for each Java. Okay, let me just do this way instead. So for each item, so for integer item in list, and we will just remove that and remove that and remove that. Okay. Set that add, not put. Run code and null, 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 true, false. Cool. Submit. Nice. A lot easier than, or a lot more complicated. I made it more complicated than it should have been, but pretty simple.